Ruth has been a student until recently at the Australian National University, and now she's working as a synthetic biologist at Nourish Ingredients food technology company, journeying from the academic to the industry world, which will be her topic for today. However, we met Ruth through the Cellular Agriculture Australia non-profit organization, where she is volunteering as a media and communication officer. Ruth, thank you for coming today. You can now share your screen.
My name is Ruth, and as Maria mentioned, I am a volunteer for Cellular Agriculture Australia, which is a non-profit organisation dedicated to promoting cell ag in our country. And as you can probably tell from the title of this talk, I've worked in both academia and industry over the past year. So I'm here to share a little bit about how I have transitioned between the two. So before I tell you about how I got to where I am, it's probably a good idea to zoom out a bit and have a look at where I came from and what drives me. So before I start on any project, I always like to think about how the work I'm doing is going to help contribute to mitigating what I see as the four major challenges faced by society. The first obvious one is climate change and biodiversity loss. This directly impacts in increasing the food insecurity that we're seeing in the world. Alongside that, we're also seeing increased antimicrobial resistance, which is set to end modern medicine as we know it. And lastly, we're seeing increased animal to human disease transmission, such as COVID-19. So the first time I ever got to approach one of these challenges, I was working on a project in which I was trying to see if there was any scientific basis for the traditional medicines used in my home country of South Africa. And I wanted to see if these compounds could be used to address antibiotic resistance. This was the first time I ever got to dive deep into the literature, formulate a hypothesis, and really take the scientific process from start to finish. And I quite literally started at the traditional medicine market, extracted the compounds, got to test them against various microbes and see how these compounds performed. And this is 14-year-old me in a research lab for the first time, completely addicted to research ever since. And that naturally led me to go to Australia to pursue a Bachelor of Philosophy. This was a wonderful undergraduate research degree in which I got to explore so many different research topics and learn so many different research skills right from first year. And after finishing honours last year at the Australian National University, I started working as a research assistant on a cancer and developmental biology project, as well as working on SARS-CoV-2 wastewater surveillance on the side. I then started working as a synthetic biology scientist at Nourish Ingredients. Nourish Ingredients is a cell ag company focused on producing animal-free lipids for alternative proteins. And now, as of a couple of weeks ago, I have recently started my PhD at the University of Melbourne in immunology and infectious disease. So how do all these skills that I've been gaining over the past few years help me work towards reducing those challenges that we mentioned earlier? So recently I sat down and I looked at all my skills under the microscope, took a really good look at them and scrutinized what I have to offer the world. And what I saw is that I could group my skills and interests roughly into 4 groups: plant science and ecology, cell biology, human anatomy and physiology, and infectious disease and immunology, which is what my PhD is in. And I'm sure you can see how these research areas could address individual challenges that I mentioned earlier, or maybe 2 at a time at most. But I wanted to see, was there a way I could address all 4 challenges at once? So this is when I looked at the challenges again, and I thought, how are all of these linked? And what I saw was one defining feature which was causing all of them, and that is industrialized animal agriculture. So although industrialized animal agriculture is a lot more efficient than it used to be, and it's definitely making vast improvements, it's still highly inefficient and it's not good enough. So to walk you through a few stats, which you're probably quite aware of, to illustrate how animal agriculture is causing some of these challenges that I've mentioned, you can see that it is really inefficient in energy conversion. So to create 1 food calorie for a human to eat from a chicken, you need to feed that chicken 8 feed calories. To produce beef, it's even worse. You need to feed the cow 33 calories to just get 1 in return. A 3% conversion rate is simply not good enough. And then there's the issue of land use. Of the Earth's 21% habitable land, 50% is used for animal agriculture. And 70% is actually dedicated to livestock use to only produce 33% of the world's protein supply. So how on earth are we going to feed 9.7 billion people by 2050 without sacrificing our planet? Well, the answer is simple, right? Let's all just go vegan. Yeah, well, that's not going too well. In fact, we're trending in the opposite direction. On average, meat consumption is increasing globally. So clearly, eating meat isn't something that's going to go away anytime soon. But that's okay, because eating meat isn't really the problem. It's how we produce meat that's the issue. And that's where cellular agriculture comes in. So as I'm sure a lot of you are aware, cellular agriculture is the production of meat directly from animal cells rather than raising and slaughtering the animals. Not to be confused with plant-based meat, which I will touch on in a minute. So briefly, how does cell ag work? We're able to take a small biopsy from an animal, which then continues to live a happy life. We can expose these cells to growth factors, which allow for proliferation of the cell, so increasing cell number, as well as growth factors that induce the cells to differentiate into the different cell types that make up the muscle tissue we know as meat. So I could see how all my skills I'd been developing in cell biology and molecular biology would be useful in helping me contribute to this field. But as I dug into cell ag more deeply, I realized that it's not just meat we can make with cell ag, it's also other animal products, such as eggs or milk, leather, even pet food and breast milk. But the product that really stood out to me was lipids. And the reason for that was when I went and dug into how we make lipids using cellular agriculture, I realized that this novel concept was not so novel after all. In fact, the way that we make lipids through cellular agriculture is the same way we now make insulin, for example. Previously, we used to sacrifice animals to get insulin for diabetics. Now we get bacteria to make it for us. And when I looked at the process, I realized that although I hadn't been calling my work biotechnology or cell ag, it was the exact same thing I'd been doing to study the proteins in my previous research. So I realized that I had the skills needed to contribute to cellular agriculture. So that's when I discovered the term precision fermentation. And that's just the food science word for using genetically engineered microbes to produce a desired product, such as proteins or flavor molecules, or in my case, lipids. And this is where we go back to plant-based food. So cell ag or cell cultivated meat is a long way away, but plant-based food is here. Plant-based meat already is available on the shelves, and I'm sure many of you have tried it. And a lot of you will know that it just doesn't quite taste the same. It really doesn't live up to consumer expectations of meat. The sensory and functional attributes of these products are just not the same. However, fat is the secret ingredient in pretty much all good food. And Nourish Ingredients, the company that I started working at, really understands that. Nourish Ingredients aims to make bioidentical animal fats without the animal. So I was really intrigued by this idea and wanted to know more about the process behind it. So I reached out to the CEO of Nourish Ingredients and had a chat about what their company wanted to do. And after that conversation, I was offered a job at Nourish Ingredients. So I joined this wonderful team of people and started using yeast to produce, animal-free lipids for alternative proteins. So what skills did I need to go into this job? I had never ever worked with yeast before in my life. So that was interesting. But what I did realize is that all the cell biology, molecular biology, biochemistry skills I'd been developing over the years were highly transferable. So that's what's really wonderful about having these core competencies which you can move between different platforms. So I'd worked in many different types of cells before, never yeast. However, it was an easy transition. So that's one thing I'd really like to point out to people wanting to transition into industry or any other job, you really don't need to have the exact skills you're required to have to do the job. You just need to have those base skills and a willingness to learn and diversify, be flexible, as well as just enthusiasm to get involved. I hadn't done any of this work before, and yet right from day one, I was able to use my prior knowledge and adapt. So that's really important, especially in a startup, being flexible. So not only did I work in the synthetic biology team, I also got really involved in the food science and analytical chemistry side. And as you can see, for me, that involved a lot of fun playing with tiny glass vials, which I had a great time with. But not only did I get to transfer between technical teams, I also had the opportunity to work on the marketing and communication side of Nourish ingredients. So we know a number of the current technical challenges facing cellular agriculture. For one, immortalized cell lines, developing 3D scaffolds to produce meat that replicates the texture and structure of whole cut products that we so love, as well as scale and automation of the whole process. And then, of course, developing serum-free media, which the wonderful iGEM Uppsala team is currently working on. But an almost equally challenging problem to tackle is the cultural acceptance of these foods. So often when you read an article about cell-cultivated meat, it is accompanied by a picture such as this. And now not only is seeing meat in a Petri dish or a test tube just completely inaccurate, it's also highly off-putting for so many people. No one wants to think about their food coming from a chemical-filled lab, but we know that this is not really the case. So what my job now in the marketing and communication side of Nourish is to help shift that customer perception of cell-based meat and make it more realistic. So as you can see, this is what cell-cultivated meat actually looks like, thanks to Mosa Meat and Wild Type for the beautiful images. So to make customers get on board with the idea of cultivated meat and really accept it as something clean, safe, and healthy, we need to change the narrative. And part of that comes down to educating the public. So now that I have moved states and universities, and of course, I'm no longer able to work directly in the lab of Nourish ingredients, my role has taken on an entirely communications side. So in order to educate people and make them less scared, we need to break down the science for them. And these are some of the skills that I have been working on developing over my undergrad years. So of course, the skills I needed to get into the industry in the first place were the technical skills. But now, in order to stay working at Nourish Ingredients, it's been those soft skills that have allowed me to continue. So what I failed to mention when I walked you through my little career journey earlier on was that while studying my formal training, I was also highly involved in volunteer activities and extracurriculars in which I was able to develop my communication and management skills. So for example, while I was in undergrad, I was the president of the university's Science Society for 2 years. I also was the student representative to the College of Science, Health and Medicine. I was the research editor for the Student Campus magazine. And I also volunteered at our National Science and Technology Centre in Australia, volunteering as a science communicator to young children, getting kids really excited about science. And to do that, obviously, I had to really break down scientific concepts and communicate it really well. So all these extra activities, which weren't part of my formal education and formal work, have really helped me build these soft skills, which I think are honestly as important as the technical skills I learned at university. Then moving on, while working as a synthetic biologist, I have continued to work in a media and communications capacity as a volunteer for Cellular Agriculture Australia, which I'm clearly still doing. And because of this, I've been able to continue my work in industry in a science communication and marketing capacity for Nourish Ingredients while pursuing my PhD. And I think a really important thing to highlight is that it looks like I had a really linear career path here, but all these things overlapped quite significantly. While I was working as a synthetic biologist, I was simultaneously still on the COVID response team. And people might think that, you get distracted by having too many things on your plate, but actually I found that being involved in multiple things really bolstered my ability to do my best work in the individual project that I was working on at the time. For example, certain skills that I picked up while working on the COVID project helped me do better work at Nourish, and I was able to solve some of the technical challenges we were having at Nourish from things that I learned the week before doing COVID testing. So really keep in mind that diversifying your skill set and being involved in multiple different projects can really be to your benefit. So the question is, how can you get involved in industry and how can you make this transition? So my first piece of advice is to understand what drives you. Know your motives, know what your goals are, and know what you want to contribute to the world. You're going to do your best work on things you're passionate about. So really just understand what makes you tick. Next, you need to figure out what makes you unique. So many people are going to have the same technical skills as you. But what is it about your combination of experiences, skills, your worldview, your personality that makes you stand out, that makes you different, and makes you right for the role? Next, as I've mentioned many times, you need to hone your soft skills. Communication and management are essential, especially in industry involving scientists. Unfortunately, many scientists fail to develop these skills. It's not valued as much as in other fields, but it will really stand you in good stead. And I firmly believe this is the reason that I've been able to continue in industry while simultaneously working in academia. Be bold and take initiative. I got my job at Nourish Ingredients by reaching out to the CEO and wanting to talk about his business. Sometimes you just have to ask for what you want. The worst that can happen is that you'll have an interesting conversation and the answer will be no. You lose nothing. Next, look for knowledge and skill gaps. If you can anticipate what a company might need before they even know and tell them how you can contribute to make their company better, you're almost certainly going to be valued. When I was leaving Nourish Ingredients to start my PhD, I knew that the marketing team needed more of a science communication role. And I offered up my skills and I was immediately asked to stay to do that. So if you can anticipate what a company might need, you might have an easier time finding a role in industry. And lastly, I'm sure you've heard this a million times over, you need to network. You need to build connections. You get jobs off by knowing the right people more than having the right skills. Unfortunately, I did not realize this for a very long time, and I was quite late to the party with networking. I've only really started to do it in the past year, but as I'm sure many of you know, it is essential. And it's also easy once you start. It just takes one contact, reaching out to the right person once, and so often that'll lead you to build another network through that person you initially reached out to. And if you're still feeling a little bit lost and confused as to how you can transition into industry, Cellular Agriculture Australia has developed a wonderful tool called the Pathways tool, which will help you understand how your majors and interests can contribute to the field. Or alternatively, it helps you understand how certain problems which need to be tackled in the industry need to be solved, and how you can put your skills to use to work on certain challenges. So I highly recommend heading over to the Cellular Agriculture Australia website and having a look at this page and having a good play with the tool. It's really excellent. So with all of these points in mind, it's now over to you to take them on board and infiltrate industry.